Pair of linear equations with two variables. First, let's see linear polynomial. Let f of x equals to 2x plus 3. And this will be the graph and it will be a straight line, right? So let f of x mean it's y equals to 2x plus 3. Then 2x minus y plus 3 equals to 0. And this will be the general form of linear equation. Ax plus by plus c equals to 0. Let us take two linear equations now. Let first linear equation be a1x plus b1y plus c1 equals to 0, and second equation be a2x plus b2y plus c2 equals to 0. Then what are the possibilities of two lines? First one, they can be parallel, or they can be intersecting, or they can be coincidental. These are the three possibilities, right? Parallel, intersecting, and coincidental. So let's discuss about these in detail. Let's take some examples. First figure they are intersecting, so they have one solution, and in second figure they have no solution because they are parallel, and in third figure they have infinite number of solutions because they are coincidental. And let's see about these in detail. A1 by A2 it will be 3 by 1, and B1 by B2 will be minus 1 by minus 1, that equals to 1. C1 by C2 will be 1 by 2. And for second one, A1 by A2 equals to 1, b1 by b2 equals to minus 1 by minus 1, that equal to 1, and c1 by c2 will be 2 by 0, that is not defined. And for the third equation we'll have a1 by e2 equals to 1 by 2, b1 by b2 equals to minus 1 by minus 2, that equals to 1 by 2, c1 by c2 equals to 2 by 4, that is equals to 1 by 2. Let's by observing we can see that in the first figure a1 by a2 is not equal to b1 by b2. In second figure a1 by a2 equals to b1 by b2, that is not equal to c1 by c2. In third figure a1 by 2 equals to b1 by b2 equals to c1 by c2. These are the observations made. Let's summarize this. In intersecting lines a1 by a2 is not equal to b1 by b2. These lines are called consistent and independent, and these have one solution. Intersecting lines have one solution. For parallel lines, a1 by a2 is equal to b1 by b2, that is not equal to c1 by c2. These lines are called inconsistent lines. They have no solutions. And for the third set of lines, a1 by a2 equals to b1 by b2 equals to c1 by c2. These are called consistent and dependent lines, which are coincidental, and they have infinite number of solutions. Let's now try to solve these linear equations. Let's take two examples. 3x minus y plus 1 equals to 0 and x minus y plus 2 equals to 0. We have two methods to find solutions, elimination and substitution method. First, let us see about substitution method. In this method, we'll first find the value of x or y in one equation and we'll substitute that in another equation to find the remaining. Let's see this in example. For example, here we'll take y equals to 3x plus 1 by sending y to RHS. We'll substitute this y in second equation. We'll get x minus of 3x plus 1 plus 2 equals to 0. So it will be minus 2x plus 1 equals to 0, and x will be minus 1 by minus 2, that equals to half, and y will be 3 into 1 by 2 plus 1 from first equation, y equals to 5 by 2. And for the second method, we'll use elimination method. We need to perform arithmetic operations so that one variable will be eliminated and other variable can be determined. Here, let's multiply second equation with 3. So when subtracted, x will be gone. And then we can determine the value of y and we can determine value of x from that. So we'll write first equation 3x minus y plus 1 equals to 0. When multiplied by 3, second equation becomes 3x minus 3y plus 6 equals to 0. And subtracted minus y plus 3y plus 1 minus 6 equals to 0. 2y equals to 5 and y equals to 5 by 2. Let's substitute y value in first equation. 3x minus 5 by 2 plus 1 equals to 0. 3x equals to 3 by 2 and x equals to half.